Hello, this is Naim Kenan from Fabmetrics, and you are welcome to our predictive quality demo today. We will focus on our cycle analysis tool of our Fabmetrics product, and I will make this demo with the help of Ali and Tuğçe from our team and Rafael from our client Ska Technology. So, let me give a little bit introduction about ourselves, then we will go to the technical parts. So this is Naim Kenan, as I mentioned. We started Fabmetrics products 4 years ago with the goal of making Industry 4.0 accessible for any size of industries. In that sense, we developed a product which is focusing on manufacturers and also for OEM machine builders. So Ska Technology is one of our clients, and Rafael will give more details. But as a company, they are giving maintenance service and automation service, and they make their products on the field connected with our system, and with their help, we developed a cycle analysis tool for cycle-based production, and we will make this demo for you on the test environment of SCA's injection molding machine. So let the others introduce themselves. Let's start with Ali from our team. Go on, Ali.
Yes, hi all. My name is Ali. I'm a backend engineer in Webmetrics. So me and Tuche here on behalf of team, I want to talk a little bit about the team we work with and what we do. Developing IoT part is under supervision of OR and in cooperation with Valdemar. At II part, we have Or and Tucha. Uh, uh, we set up a pipeline with Okai, and we have the superhero Talha. He's working like a full stack engineer. So he is working on front end side, and me and Talha in back end side. I think that's all. Thank you.
Thanks, Ali. And Tuğçe, please make your introduction.
Yes, hello. My name is Tuğçe Nuraskan, and I start this company by the beginning of this year, and I am working with Ali about data science, and this cycle project is my first assignment, so I'm exciting. That's it.
Thank you, Tuğçe. And it is Rafael from Ska Technology. Please go ahead, Rafael.
Thank you, Kenan. So my name is Rafael Steriopoulos. I'm 26 years old and living near to Stuttgart in Germany. I work in the technical operations management for the company Ska Technology, or Ska Technologie in Germany. The portfolio of Ska includes own automation systems, for example, in the packaging industry, or services like maintenance or solving technical issues. But we also have developed a solution with smart maintenance in cooperation with Fabmetrics, which Kenan will introduce later in detail. Yeah.
Okay. Thank you, Rafael, for your introduction. And today, indeed, we will talk about our predictive quality functions of the system. So let me give a little bit information about our project and our product. Then maybe meanwhile, you can go to the testing environment for today while I am making this introduction.
Yeah, sounds good.
Okay, let me start then. Okay. So with Fabmetrics, indeed, we deliver 4 products. I will not go in detail about these products, but I will talk about the solutions today. And with Fabmetrics product, indeed, we make factories connected, and how we make them connected is we firstly we collect the PLCs or other data emitting systems like quality control points or any other external sensors, and we collect all these data, IoT data, and we create a big data warehouse on the cloud. And based on this data warehouse, we are running our AI algorithms over the pipelines. And with these AI algorithms, our objective is to increase the production efficiency. And I will give the details of these AI algorithms later on. Another solution sphere for us is Fabmetrics OEM machinery. As I explained to you, the service that we give over our product to factories, that can be also given by OEM and machinery industry, also for system integrators or service providers like SK Technology, who is the topic of today's demo. So what we do is we give them our platform, so they give the services that we offer to the factories with their own label as their own digital service. So what kind of digital services they can give? First, they can provide their clients a customer portal or an IoT platform, and also they can offer the AI models that we developed for specifically for these machines, or our generic models as well. Other solution sphere of Fabmetrics is first two things that I mentioned are the products, but we have also services. In our product, you will later see on our manufacturing process model library module, we have algorithms based on these areas: adaptive processes, predictive maintenance, and predictive quality. So these are the on-the-shelf AI algorithms to be used. And if the end user, I mean the factories or the machine builders, can use these algorithms, and if they want better performance of these algorithms, then we can fine-tune these algorithms for them, for specific for their process or for machines. Or any other cases, they can have specific case which cannot be solved by our on-the-shelf algorithms. So we can develop algorithms which are customized to their specific problem. So this is our Fabmetrics introduction. Let me show you a little bit our product, so that will make you a better understanding. So this is our platform indeed. So in this platform, as a manufacturer or as a machine builder, you can have lots of factories or machines that are dispersed over geographies. So with our product, we make them connected, and all IoT data on these machines or on these lines are coming to our systems. So as you can see in here, every production line, every machine which is connected to our system is, as you can see here. And under every machine, there can be lots of assets that can be a motor or any other equipment. All these equipments are equipped with sensors, as you know, and we also get this sensor data over PLCs, and we have the digital twin of all these machines in this way. So this is Fabmetrics in Fabmetrics general view. The topic of today is our predictive maintenance, predictive quality models. So all our predictive models or AI functions are offered to our clients over our manufacturing process model library function, as you can see here. So in here we have different teams. One of them is, for instance, smart maintenance models. So let me go there. In here, you can see different models, and these different models can be configured by end user as an AI agent, and they can, monitor their assets, their equipments over the sensor data that they, I will show you here. as they add the sensors in here, and the system continuously monitor this sensor data and give the algorithms give the outputs. So what could be these outputs? For instance, I just opened animal detection algorithm. For this kind of algorithms, the output is if there is an anomaly, then the system sends the anomaly. For instance, here is the output of the one that I showed you. When there is an anomaly, system sends us a message that there is an anomaly, and also it shows you the contribution of each sensor data to this anomaly. So the idea in here is in our manufacturing process model library, users can generate several AI models, and with these AI models, AI agents, these AI agents are tracking or monitoring complete factory or production line on behalf of the management teams of the factories. So this is a short introduction about Fabmetrics. As I mentioned before, SCA is our client as an OEM and machinery. In here, we can also provide our product as white label with the customer's look and feel and logo. So let's go to SCA right now, and let's hear from Rafael about our today's testing environment. He will give us an introduction about the testing environment. Rafael, please go on.
Yeah, thank you. I hope you can hear me clear because of the machine, but I will give my best. So, as you can see, we have the same cycle analysis data chart over here, and it shows us actually the inlet and outlet water temperature. And this is what I will today manipulate. So the outlet water temperature. But first, I will show you the system and how it works. So here you can see an injection mold machine with a mold which has 6 cavities. And this is producing cups like this. And the cup looks like this. And as you can see, all these cups looking good, looking pretty good. So now, when the cups are good, I will go and manipulate the cooler. This is the cooler. And I will go down. So now we have 15.4 degrees. And I will go down to like, let's say 8 or 7 degrees and see what's happening. Yeah, let's go for 7. This is, by the way, our own automation system. And this tiny thing, this small thing is our Beal and Edge device. But later more. One look at the cup again. So to the Bienen Analytica. what is it, and how does it work. So, Beeline Analytica gives you the ability to remotely monitor, control, and analyze your processes and energy consumption anytime. Sensors can be easily connected via plug and play to one closed cloud network. The integrated Beeline cloud offers you a variety of further functions, from an alarm function in the event of a device of planning, documentation, and management of activities like maintenance services. So you have no more paperwork, everything is stored digital. Yeah.
Okay, Rafael, thanks for introduction.
Yeah, thank you.
So let me give a little bit information about today's use case. So we will talk about the predictive quality tool of Pubmetrics. So what we do as you see on our manufacturing process model library model, we have predictive quality functions. In predictive quality functions, we have two different approach. One of them is time series analysis, other is cycle analysis approach. The use case that Raphael showed is injection molding. So in injection molding, the system is making cycles for each production. So these cycles are already indeed, I can show you here. This is the device that Raphael just connected. So we receive data of machine concurrently, and we can easily see right now the cycles on the production. You see before it was, these are the cycles. So as the system starts to get the cycle data, it determines a reference cycle. Then with real-time analysis of each cycle, we check the existing cycle with the reference cycle and previous cycles, and we try to detect the changes or anomalies in the cycles. And when we find an anomaly or change in the cycle, then we try to define it and categorize this change. And when we do this defining and categorization, then we can send actionable insights to the operator. What I mean as an actionable insight is so a message that gives there is a problem and what could be the root cause and what could be the impact in terms of the quality. So let's see the data right now, and then we will also connect to system to workshop. Indeed, let's go to workshop first. Rafael, are you with us now?
Yeah, I'm there.
Did you
to decrease the temperature? So
still
you
it's
can
going
see
down.
an impact. Yeah, exactly.
Okay, so then let me show the data.
Yeah.
I think till you get the not okay products.
Yes.
Okay, so firstly, start with the AI pipeline. In here, you see the as Sky is our OEM client, we give white label our product. In here, you see the predictive quality models. So right now we are indeed seeing the machine that is called BLAN, which is connected to our system or BLAN H device. You see all the sensor data coming from the machine. These are for instance, right now we are focusing mostly on to the water going to the molding because Raphael made the manipulation at that site. So all these data is used for our AI model. In here, for cycle analysis, we already made agents ready to use. So for this machine, we set up an AI pipeline to detect the short run problem on this injection molding. And as you see, every minute our system will check the data the sensors that are attached to the system. And based on the analysis of the sensor data, it makes the cycles of the production. What I mean the cycles of the production, let me make it a little bit visualize for you. So right now we are talking about this device. So you see this device has lots of sensors, this machine. So as right now we are focused on the water related issues, and Raphael manipulated these sensors. So by cycle, I mean, you see the machine was working almost with a cycle time of 5-6 seconds. You see from 1745-50 the data came. Right now it is 1746. So the previous data was on 1744 from this sensor, so water volume sensor. So let me show it on the chart. You see it's going down. The green line is the reference that is drawn by our system for this sensor data. And after the manipulation, it is going down. So Raphael also made a manipulation on the water temperature, as you can see. Let me close the other data meanwhile. So you see. So as we visualize in here at the backend side, our algorithms are checking these differences on cycle, and based on the deviation, we try to find out the anomaly, and based on the categorization of the deviation, we try to go to root cause and the possible issue that is about to happen on the production side. So as you see in here, that was the data that we are checking. So when we check the same data on time series for this sensor, we will see. So these are the manipulations started, and that should turn for us as a notification on our how to say AI agent. So let's go to our AI agent, which was defined in here, predictive quality, the last one. So here is our sensor, not sensor, sorry, AI agent. So if you come to the alarms of it, you see by right now it is 1748, and Raphael made the manipulations around 1744, and at 1746 of today, we get this message about this short run risk. So possibly that has already gone to emails of the related people also, which one of them is me. Yeah, as you can see, short run risk is detected for this machine, and it gives also us about what kind of check should be done by the quality department. So there's void risk, and it gives also information about the anomaly caused sensor. So it says check the water outlet temperature. So this is how our system is working indeed. So our system gave a notification that there can be a short run on the production. And let's connect to Raphael and see if there is a short run there.
Yeah, thank you, Kenan. So let's check. Here are the products. So let's look at a good cup. For example, like this one. You see, it's looking good. But when I see this one, moving,
Yeah, short run
can
defect.
exactly. You
Yeah.
can see that from here to here, it's material missing. It's not put anymore right. You can also see it like here. So all the cavities are not good anymore.
Yeah. Yeah. Rafael, can you show the machine, the new products that are coming from the production with your camera?
Sure.
Yeah.
Like this one are new. Or even better, let's go like these right here. I will bring it to me and look at it. So for this one, you see it's good?
Yeah. Thank you, Rafael. Thank you. So let me give a little bit more information about how we can implement this tool for other industries. This is also important. So right now, in this case, we saw the implementation of our product for injection molding, and we, as you see, we had the cycles and then we detect the deviations. But this method can be implemented for any kinds of the manufacturing method which has cycles. For instance, for rubber production, it could be curing press, or again for plastics, it could be, for instance, thermoform process. Or for metal, we can also use it for spot welding process. Even the cycles are very short there. As long as we have high resolution data, we are able to detect those kind of problems. So thanks for your listening, and I hope we will be able to give you an idea about what we do on plastic injection. So and maybe in other videos we will give you more information about the other kinds of production like rubber, etc. So Rafael, Tuğçe, and Ali, thanks for efforts today, and
Thank you.
Thank you too.
hope to see you at the
Thank
next
you.
video.
Yeah, I hope so.
Okay. See you.
Bye bye.
Bye bye.
Bye bye.